Welcome to another edition of our Lift Off webinar series. My name is Joe Steele. I'm the Senior Director of Communications and Legislative Affairs with Lyft. I want to thank you for taking time to join us today. Today we are happy to welcome MAHLE to talk a little bit about some innovations in powertrain cooling solutions. We are very happy to have MAHLE, Ciro and his team as members at Lyft, and we're excited to hear what they have to tell us about powertrain cooling solutions today. So Ciro, thank you very much for joining today. I know you have some other folks that are attending as well, and we may hear from them a little bit later. So a few housekeeping issues before we get started. Again, this webinar is being recorded, and we will post it up on our website at lyft.technology. Either later today or tomorrow, so you'll be able to revisit it then, or share it with folks who may not have been able to join and you think may be interested in today's presentation. If you do have a question, encourage you to use the Q&A function that we are all too familiar with using these remote and virtual work settings that we have, maybe hybrid at some point now. But use the Q&A function and we will facilitate the Q&A afterwards. Everyone should be muted right now, but if you are not, please do so, just to make sure that we avoid any background noise for the future recording. Again, hope everyone is safe and well as we continue to work our way through this pandemic and hopefully back to some sense of normalcy in the near future. And we look forward to seeing you at our Lyft facility as soon as we can. Before we get to MAHLE, I do want to spend a couple of minutes to talk a little bit about Lyft for those who may not know who we are and what we do. Lyft is one of 16 national manufacturing innovation institutes around the country. And our goal is to drive American manufacturing into the future through technology and talent development. We believe that the future of our national economy, national security and resiliency rests on smarter manufacturing. And the next region, the next area that tackles smarter manufacturing first is going to come out ahead. And as a Department of Defense Manufacturing Innovation Institute, we want that to be the United States of America. So when we talk about smarter manufacturing, what do we mean by that? At Lyft, we mean the manufacturing equation, the connection between materials, processes, systems, and the talent that runs underneath all of those. So at Lyft, we operate two programs. Our technology program, which is leading innovations for tomorrow, and our talent program, which is learning innovations for tomorrow. You can learn a little bit more about both of these on our website, and I'll touch a little bit about them on both of them here today. On the talent side, or the technology side of the house, leading innovations for tomorrow, again, it's about connecting materials, processes, and systems. You can see our four main pillars of technology that we're working on, all the way from integrated computational materials engineering, the digital side of things, to agile, smarter manufacturing, advanced alloy process development, multi-material joining. As we're developing these new materials, as we're developing these advanced alloys and new processes, how are we going to join all of these things together? A little bit deeper into each of those pillars of technology. I won't quiz you on these, but just shows you the depth and the breadth that we have, not only in our in-house facility in the Corktown neighborhood of Detroit, but around the country with our members and folks like MAHLE. So again, you can learn a little bit more about these on our website, or certainly reach out to us with any questions. On the talent side of the house, learning innovations for tomorrow. Again, it's still about innovation, but new learning tools, pathways, and venues. We kicked that off with our Ignite Mastering Manufacturing curriculum, which is a 3-year high school curriculum, which is available around the country. We do teach it at our Corktown facility here in Detroit, and that is again a 3-year program, high school students really to open their eyes to advanced manufacturing. We really host that at the Lyft Learning Lab, which again is at our facility in Detroit, but the curriculum is available around the country. It's available in about 11 states now. But the Learning Lab is an immersive lab where folks get to come in here, students get to come in, and really while they're learning about advanced manufacturing, they get to look out the windows and see our technicians, see our ecosystem hard at work, developing some of the new technologies that we just talked about earlier. And we also offer world-class certification programs on our own at Lyft, but also through a program we call Operation Next, which was developed as a military-focused program to help our men and women in the military before they separate from the service, to 6 months before they leave, to give them the opportunity to earn the credentials in some of the most in-demand jobs. These are nationally portable, industry-recognized credentials. We have been slowly expanding this program. COVID kind of slowed us down a little bit. Began as a pilot at Fort Campbell, Kentucky. It has since expanded to the Florida National Guard and Reserve, the Michigan National Guard and Reserve, the Wisconsin National Guard and Reserve, and stay tuned for another base announcement coming up shortly. So not only are we preparing folks for the jobs of tomorrow with our high school program, but also preparing folks for the jobs that are available right now today. Finally, I mentioned we are a membership-based organization. I would be remiss if I didn't tell you what that meant for us. We are a nonprofit 501c3 based here in Michigan, but all of our members get to enjoy some of the benefits that you see on your screen here. We are a trusted advisor. We're not here to sell a particular service or product. We're here to give you the best advice that we can from our ecosystem, from our in-house decades of experience to help you make that transition towards smarter manufacturing. We're a technology accelerator. We went through that a little bit earlier. All the different technology areas that we work on, we're looking to take these concepts to commercialization as quickly as possible. Technology showcase. I hope you guys get to come to visit us at Corktown next time you're in Detroit, as soon as possible. In the meantime, you can visit our virtual tour on our website and see how we are showcasing the art of the possible with advanced manufacturing. We're a connector and a convener. That's why we're all here today. So thank you so much for joining us, bringing the best and brightest together to talk about what's going on in advanced manufacturing. We are a talent developer. Already touched on that with our high school programs and our adult learner programs. And finally, we are a government partner. I mentioned we are a Department of Defense sponsored Manufacturing Innovation Institute. It can be overwhelming for folks to try to work with the federal government, but we can be a conduit to do just that. So encourage you to reach out to us on our website via email, give us a call, follow us on our social channels. Happy to connect with you, and we can talk to you more about membership and the benefits that lie there, and what else you can learn at Lyft. In the meantime, you wanted to hear from MAHLE today, so I will hand the presentation over to Ciro, and I'm going to stop sharing my screen so he can share his. Ciro, the show is yours.
Thank you very much, Joe. So thanks, Lyft, for having us in that community. We're happy to have joined and to be part of Lyft, and it's an honor to be here and to be in that group. Yeah, thank you. First of all, maybe a quick introduction. My name is Ciro Vieira. I work with MAHLE been working with them for the last 17 years with assignments in Brazil, in Germany, and now since 2016 I'm here in the US, and I'm heading the sales and business development function of our MAHLE Industrial Thermal Systems division, right? So we'll be going through a little bit of MAHLE, and so that would be clear, hopefully. So what does industrial thermal systems mean within the whole MAHLE, right? So better to start, go straight to the presentation, and then we can I can clarify a little bit of organization here. Yeah. Okay. Let me move on here. So MAHLE is a global company headquartered in Germany, right? So we have more than 70,000 employees worldwide in 160 production locations, more than 30 countries, right? So we are really global. So with sales of about 10 billion euros last year, so was not the best year for, I guess, for most of us, right? So, but that's the magnitude of how big MAHLE is, and we do have 16 major development locations, more than 6,000 engineers across so many different countries in Europe, North America, South America, and Asia, right? So MAHLE, so just before we get into the thermal industrial thermal management division, right? So MAHLE is a major automotive components manufacturer. So with a strong presence in the automotive industry with many different products. But here we are not focusing on much on the on-highway automotive or passenger cars and truck applications. So we are here to present our industrial thermal system division, which is focused on basically everything which is not a passenger car or a on-highway truck, right? So what we call it industrial applications, but it's actually much more than that, much broader than that. So we are talking about applications of thermal systems, right? So powertrain cooling systems and air conditioning systems in some cases for rail vehicles, for military vehicles, industrial and marine engines, construction, agricultural machinery, and as well some applications on buses and special chassis, right? The Industrial Thermal Systems division of MAHLE so has about 850 employees and makes roughly 200 million euros in annual sales. These are global figures and not only for North America, right? Here, getting to our local plant here. So we are located in Belmont, so just north of Grand Rapids here in West Michigan. So the operation in this site here started in the year 2000. We have shy of 100 employees in a production area of about 63,000 square feet, in a warehousing area of more than 33,000 square feet, right? So we are IATF 16949 certified, so ISO 14000. We are as well ITAR and STA compliant for military programs, right? So the main products we produce here in the Belmont are heat exchangers and cooling modules, right? So both for new vehicle builds as well as for sustainment spare parts, and you're going to see a bit more details later in the presentation. We as well have a service or a remanufacturing operation here in the area as well. Okay, so just a quick overview of our plants here. So that's what we call plant one. So focus basically on aluminum heat exchangers manufacturing. So plant two, we have some applications of stainless steel and copper round tube for really heavy duty applications. Plant three, we have here final assembly and as well our service remanufacturing location. Okay, so we'd like to share some benefits and strengths of MAHLE, right? So, and one of the key markets we are targeting here in North America, and one of the main reasons we have partnered with Lyft, is to expand our footprint on military ground vehicles, right? So MAHLE has over 70% of the cooling systems market for military ground vehicles in Europe, right? So we have a very strong presence, and we are very well known of being so not only market but as well technology and reliability leader in that market. Here in the U.S., we do have a presence since many years already, but we decided back in 2018, right? So to really put more focus and try to grow our footprint on the military business since a bit more than 3 years now. So we do have some applications you're going to see here be produced in the US, but still we understand a long way to go before we can call ourselves one of the major players in the market, and why not try to show our value and get a bigger stake of market share in the US as we do have in Europe. Okay. So although we are a German company, right? So we have our manufacturing locations here in the Grand Rapids area. So we are used to deal with Buy American requirements. So we can easily provide 70% or even more local content to on the products we manufacture, right? So we do have as well our own product engineering design capabilities on site, right? So where we can lead most of the developments of new programs out of our local engineering capabilities, right? And of course, we have program management, so we have our own prototyping and testing area, and as well our aftermarket support on both new parts and as well remanufacturing, right? So we proud ourselves to have state-of-the-art engine cooling systems and technology, right? So and are always looking ahead and trying to be ahead of competition on next generation. So especially when it comes to electrification of powertrains, as well as so not only battery electric but as well fuel cell applications. So we try to stay on the edge of those technologies to support any market should that shift come. Yeah. We one thing we understand we are strong as well. So whenever you're going to learn, right? So MAHLE is probably not the cheapest player out there, right? So whenever we are talking about an off-the-shelf, simple, cheap solution, so we are probably not the best partner for those kind of applications, but we are well known both in all the markets we participate to be the best when it comes to solving complex issues in terms of what is the performance requirement needed for that specific thermal management application, or packaging requirements, or all together, right? So that's usually the case on military vehicles. So that's definitely one of the most challenging markets we act on in terms of all those restrictions, and we proud ourselves as well to be to be a problem solver whenever it gets complicated, right? So we do have as well our own simulation and system modeling platforms, right? So we'll get a little bit more on those details later on in the presentation. But we do have our modeling simulation systems, so they are very precise in terms of predicting the behavior on actual applications, and those systems are constantly being updated, and they do receive feedback from actual field or lab measurements, so to make the system constantly evolving in terms of accuracy. A little bit of what we do here for military applications, right? So these are a couple of examples of what we produce here, right? So the main one, and I guess some of you guys have heard about it. So we are the current supplier for the complete engine cooling module for the Humvee. Lately, I think 1.5 years ago or so earlier last year actually. We developed the one new piece for that module, right? So we used to have only that black oil cooler for that vehicle, and then so we were invited by AM General so to develop an aluminum replacement for an old copper brass technology radiator, which was still being applied to that vehicle, right? Copper brass technology, for those who are not so used with engine cooling application. So that technology is mainly dying, right? So back in the, I think it started back in the 80s. Well, there was a strong shift, first moving passenger car heat exchangers production from the copper brass technology to aluminum, right? So followed worldwide by replacing copper brass on highway trucks. And more recently, we see that shift happening. So on all the other off-highway applications as well. So starting with construction and agricultural machinery. So I guess it's very seldom to find any either on highway vehicle or construction agricultural machinery still using or relying on the copper brass cooler technology for new vehicle builds, but there are still a couple of applications on, for example, on the rail side, on the military ground vehicle side, that still rely on that old and outdated technology. And as we see, right, so as the technology, as I mentioned, is dying, is going away for both performance standpoint as well as cost. Manufacturers are seeing are of those of that old technologies are going out of business. They are shutting their doors, having and OEMs are facing a very a big challenge on finding replacement for that. That's why we understand aluminum is the future for military ground vehicles as well. So we have a success case here where we have an aluminum radiator installed on the Humvee, so without any flaws whatsoever, and proven to be a more reliable and resistant piece of equipment. So compared to the old copper brass, yeah. Some other examples here as well aluminum coolers we produce for LAVs, and we do produce as well coolers for the Israeli military MK4, Merkava, Namir, Tiger, so all those variants of the same platform. So they are all produced here in the US and exported to Israel along with the vehicle engine, right? Moving on here a little bit of what we do for the rail market. These are some examples of charger coolers. So 3 different designs of charger coolers for rail applications, and those are cooling towers for those massive public transportation locomotives, right? So this is really big units, so weighing more than I think 7,000 or 8,000 pounds, and so it's probably some 8 foot high. So that's really massive, and that's used to cool a 4,000 horsepower plus engine on a passenger locomotive. Those are cooling towers for electric driven locomotives as well. So as well produced here in our Belmont facility. Some examples of agriculture and construction equipment, right? So a complete cooling module for agriculture tractor, as well as a single standalone radiator for the same kind of application. Engine mounted components as well as are a specialty for us. So especially when we are talking about big bore, high horsepower engines, right? So this is an example of a charger cooler, which is mounted on one of those big stationary engines. So in this case, I think it's an MTU engine. But yeah, we specialize as well. So as we said, so when it gets bigger, when it gets more complex, that's where MAHLE usually excels on providing solutions to our customers. Some other examples here of engine mounted components for high horsepower engines. Yeah. So here we'd like to share a little bit of some details of the construction of our heat exchangers and the alternatives we have here. This is what we call a bar and plate construction, right? So this in this case, so unlike the heat exchangers, the radiators we find on our own cars, right? So if it goes to a light applications as a passenger cars, you have a tube and fin technology, which yeah, I probably explain tube and fin first and then get back to bar and plate. It's easier like that. So you have a pre-formed and welded tube which get inserted to a header, and then you have so where the fluid is going to be flowing through those tanks and through the tubes here in the core, and then the system is going to be rejecting heat, in this case to the air, through the air side fins here, right? This kind of system is much lighter, right? So and usually suitable for smaller applications. Yeah. So, and less demanding applications. Although by smaller, I even include some really heavy agriculture machinery, construction machinery, and even some military applications could use this kind of system as well. But that's what we call a lighter application within our universe of markets and applications we serve. We produce those here in Belmont out of aluminum, right? As I mentioned, so suitable for lighter applications, and lighter being in relative terms. And it usually delivers a lower unit cost if the application allows, from a technical perspective, the application allows for a tube and fin system. So that's probably what we're going to go, because that is what will be providing the best price for our customers, right? So it has a downside, which is usually when you're developing a brand new cooler heat exchanger out of this technology, you tend to have slightly higher investments on the equipment and tooling needed to produce one specific system, right? So that's why it's suitable not only for lighter and smaller applications, but as well we tend to prefer that when applications are when we're talking about higher volume applications. Okay. So coming back to the bar and plate construction, here you do not have a preformed tube to insert into a header as we've seen on the other applications. So they can look very similar from the outside, but from a construction standpoint, they are completely different, right? So here you don't have pre-welded tubes. You have plates, aluminum plates. You have bars, right? And you start stacking them together, right? So that you have your fins, a plate, some other profiles here, which in an aluminum plate on the bottom, an aluminum plate on the top of that. So, and that would be all compressed and then brazed together in our brazing furnaces, where there will be a bonding of the material here. So, and therefore the tube is going to be formed through after the assembly and braze process, and not being pre-manufactured and just assembled into a unit, right? So this they are aluminum coolers as well, right? So no difference, no significant difference in material here. And they are usually much more resistant from the sake of withstanding high operating pressures or high thermal stresses while delivering equivalent thermal performance, right? So we have a lot of flexibility on doing those designs, and as the opposite as the tube and fin. So we have more flexibility here, and we have less investment in tooling and equipment when it comes to develop a new customized solution, right? So all those features related to our bar and plate design, so make this in most of the cases the preferred solution for military applications, right? So due to first, the requirements are usually pretty stringent, and we want to have the best reliability and the best durability we can achieve with a cooler on those kind of vehicles. We cannot afford any failure on when those vehicles are there in the field, right? So and as well as when it comes due to the relatively lower volumes of military programs, so that makes it as well a choice from economical terms due to the lower investment compared to other systems. Okay, so we covered tube and fin already. So round tube production. So here we are switching from aluminum to stainless steel. Okay, and there is a reason for that. So the round tube production is usually applied to much heavier applications. So in for big industrial engines and as well for exhaust gas recirculation cooling systems, right? Um, the temperatures in EGR system faces are much higher than a regular oil cooler or coolant cooler for a vehicle radiator, right? Therefore, stainless steel is the option here. So aluminum wouldn't be the option, as aluminum would not withstand the temperatures and the requirements of such applications, right? So, but that is as well a technology we have available here to add to any application which would so requirement, which would have restrictions on what aluminum would be capable of. A fourth technology to produce heat exchangers are what we call stack plate, and in this case, oil coolers, they can cover different fluids as well, so they can cool with different fluids as fuel. They can be used even for some air conditioning condensers in some cases. But yeah, stack plate is a construction technology here, which is different from what we saw a minute ago. So they do not reject heat into the air, but that is a fluid to fluid system instead, right? So you have oil flowing through one of those circuits here, and coolant water flowing through the other circuit, right? So, and you have intercalated plates out of, so you have usually one plate channel here, so where you have oil flowing, the other so coolant water, and so on and so forth, so that you have the oil heat being rejected into the water, and then the water would flow through the coolant system of your vehicle, and that heat would be finally be rejected out to the air through the vehicle's radiator, right? So some of the we have designs for both aluminum and stainless steel. Depending on the applications, we would select one of each. So being aluminum, the one choice for the first choice for the sake of costs, right? And there are some advantages in terms of space claim here. So those are usually very small and compact units, can be mounted directly to the engine without any piping connection, right? So if you're talking engine oil cooling, right? So those have some a specific application and this specific the advantages as well. So I wanted to point out as well our capabilities here with battery cooling, right? So this is an example here of a battery standalone battery cooling system, right? So if you have a electric or electrified application, so one of those units could be added to your vehicle as well. And these would include both the compressor. So basically, most of the AC systems is comprised here. So your evaporator, your compressor, and condenser fans as well is all integrated in that standalone system here, right? And this is just a quick diagram of how does a battery cooling thermal management system works, right? So you have a battery. You need to get your battery at operating at an ideal temperature, both for the sake of holding power longer, as well as for the durability of the battery, right? So if you have your battery running outside of its ideal temperature envelope, you have definitely a reduced lifetime of your battery, right? So, and we know how big of an issue that is, right? So our system has the a condenser and a battery cooling module here. So usually in front of the vehicle with in as well an expansion valve here, so which finally so absorbs heat out of a chiller system, which then cools a fluid here, so which is finally what is going through the battery and through the cooling plates and reducing and absorbing the heat, the rejected heat out of the battery, right? And that's a closed loop circuit, right? So you have two loops here as explained. So one for the refrigerant and one for the coolant. So yeah, and both circuits are closed loop systems, so dedicated to the battery cooling. Okay, coming back to a little bit of our team and our technology in development capabilities here. So here in the US, we have a team of 5 development engineers and designers, 4 process planners, so 1 prototype technician, and we have the support of the big MAHLE, right? So this is something we used to say as well. So although we are let's say a niche application within the big MAHLE, right? So we are focused on low volume, very specific applications here. We although we are focusing here, so we can count on the technology developed by the big MAHLE, big automotive MAHLE, right? So different from other players in the market, which are only active on the off-highway segments. We can count on state-of-the-art technology developed by big MAHLE for automotive applications, and then apply that into our own off-highway applications, right? So as I mentioned a little bit the BIS simulation system. That's our thermal simulation software developed by ourselves internally at MAHLE. So as I mentioned, so constantly being fed back by actual testing results to make it even more precise. So that's just a diagram of thermal simulation performed by to a cooling system here comprised of, in this case, 1, 2, 3, 4, at least 4 different heat exchangers, right? So, and that system is capable of simulating the operation conditions, not only of individual cooler, but the interaction among all of them, right? If you have, as in this case, one cooler in front of another and then in front of a third one, so they interfere on each other's behavior, right? So the coolers in the front, so they get the cool air. So then the air which is heating the coolers behind, so they are definitely increasing temperature, right? And as well as pressure drop. So if you add, we need to consider them each one of those coolers as a restriction in front of the other, and then our software allows us to simulate what is that impact, right? So what is the reduction on airflow the cooler behind is taking from the others installed in the front, and what is the heat pickup? It's the external air is taken from one cooler, and what's the influence on the others, right? So our system is capable of doing all those taking into account all those considerations here as well. Okay. For design, we use CATIA V5, and we are as well capable of doing finite element and CFD simulations. Okay. I think I spoken a little bit about the BIS thermal system simulation. So probably a couple of things I haven't mentioned yet. So we are, of course, capable to use on every one of those coolers different fluids, right? So water and glycol mix, or a mix, or 100% water, or oil, and different types of oil, or any other fluid which is going through the coolers, right? So we have functions for each one of them, and as well as we are capable to add the influence, not only of, as I mentioned, from one of our coolers, what's the influence that cooler is having towards another, but as well some influences that other systems in the vehicle can cause, right? For example, a grid or a bottleneck on airflow or any other restriction that can be there. So when you mount the engine cooling system into the vehicle, as well as if there are other heat sources which should be adding heat, adding temperature to the cooling air compared to the ambient temperature. So are there other elements which are not within the cooling module which are adding heat to the air, so that air is reaching our cooling system in a temperature which is higher than ambient? All those external factors are as well being able to be considered on our system simulation. So some example of test benches here. So we do have wind tunnels available. So, and here we have some examples of some military vehicles being tested in some of our wind tunnels. We do have wind tunnels in Germany and here in the US in Troy, right? So and it's not uncommon to see military vehicles being tested on that wind tunnel in Troy, regardless if that has a MAHLE system or not, right? So we can not only test our own equipment there, but we can definitely sell our services if anything else is being tested on those vehicles, even if we're talking about a vehicle with cooling systems or any other systems coming from a competitor, right? On top of the wind tunnels, and by the way, so our wind tunnel is as well ITAR certified, right? So there shouldn't be any issues. So we have had vehicles tested under ITAR restrictions, and that's no issue for the wind tunnels in Troy as well. On top of the wind tunnels, we have performance test benches where we test the standalone heat exchangers, right? So we have pressure and thermal cycle test benches. This is more for validation of durability, not directly performance. We can test fan and fan clutches as well. So corrosion chambers, vibration test benches, so shaker tables, right? Basically, right? Acoustic tests, benches, and metallurgic analysis, right? So that's all in-house capabilities we have within MAHLE. Okay. Stepping ahead here, so wanted to speak a little bit about our service and aftermarket or overhaul remanufacturing division, so whatever we want to call it. So this is a picture which shows very much what we do here, right? So on the right hand side here, so we see a cooling module as it usually comes out of the field, right, after some some years of operation. And here on the left side is how does that look like after we clean and refurb it. Yeah. So that is performed on our plant 3, as I mentioned in one of the previous slides. So that's where we do all this service and remanufacturing work, as well as some final assembly and warehousing. So we do have cleaning capabilities, including ultrasonic cleaning, and we do have our own proprietary processes to repair and to test the coolers and make sure they're coming back with leak-free and in operating conditions back to the field. Okay, a little bit of our facilities here. So this is our pressure washing booth, right? So whenever a cooler gets to our location, so it's first pressure washed from the outside to get rid of all the dirt which is outside of the cooler, right? So once it's clean from the inside, so it could either go straight to those chemical soak tanks, right, to break down any stubborn dirt or even some internal dirt which could be in those coolers. So they get chemically cleaned, so they get rinsed. And then last but not least, ultrasonic cleaning is where we get rid of the remaining impurities on that cooler, right? So in some cases, we even flush the coolers from the inside, to clean them from the inside with a cleaning solution as well, right? This is a picture of a cooler as we receive it, and that's how they return to our customers, right? So in many cases, in most of the case, to the uneducated eye, so it's even difficult to differentiate a refurbished cooler to a brand new cooler out of our production, right? So the results are really really positive here. And that refurbishment can be done, of course, to a fraction of a new cooler or heat exchanger cost. Okay, yeah, just a little bit more detail on what we do here from our overhaul business, right? So cleaning, repairing, leak testing, painting, if that's the case. So we can do some testing as well to check if there are any airflow or water flow restriction on those coolers. We can do recoring, which would be to replace the complete core, which is actually the element in the heat exchanger which actually transfer heat out of a fluid out to the air or to another fluid, right? So we can do that as well, reusing the tanks and some other components and replacing the internal core of a cooler, right? And we are capable to overhaul hydraulic system and even some electric systems in some of our units. Yeah, and that concludes my presentation here. So we would be open for questions, and that presentation here, I think that will be made available to the team here and to the Lyft community, right? So I am Ciro Vieira, Sales and Business Development Manager. So we have in our team is also Ken Russell, who is the responsible account manager for military applications. Sean Hale is an account manager as well for service and aftermarket. Henny Schroeder as well is watching us here and will be available to answer any questions. He's our engineering manager. So myself, Sean, and Henny are located here in Belmont. Ken sits in his home office in Unica, right? So that we have a closer presence to our military customers, which are mostly around the Detroit Arsenal, as you know. Yeah, that concludes my point here.
Excellent. Thank you. I'm not still on mute. I thought I was still muted. Thank you very much for the presentation. Again, if anyone does have questions, please use the Q&A function, and we have a few minutes to ask some questions. But as you guys can see, materials, processes, and systems go all the way through what MAHLE is doing specifically with cooling systems, which is great to see. And if you haven't had a chance, so we were lucky enough to tour their facility over in Belmont a couple of months ago. Awesome place to check out and visit and see how much work is being done there, and how many people are there actually doing the work. It's it's not a lot of hands-on work, let's say, to make sure this stuff is done well and done correctly. I know you guys are a recent member of Lyft, and someone asked if you'd been involved in any of our technology projects. I don't think you have been just yet, but I know that one of the things that interested you in terms of becoming a Lyft member is that government partnership that I talked about earlier, in terms of and you spoke on working with the DoD. Can you talk a little bit about the benefits of transitioning some of those cooling components from copper brass to aluminum would have for the Department of Defense and those vehicles?
Of course. As I mentioned, so copper brass is a technology which is dying, right? So it's going away from the market. we are down. So all the major manufacturers, and MAHLE, we used to produce copper brass coolers as well. It's in many different locations worldwide. So and I think we have shut down our last production facility more than 10 years ago already. And that is happening with all the major or global technology leaders, right? So I don't think there is a single one who still produces copper brass coolers.
Is
That
it
means
cost? Is it efficiency? What that they're closing down shop like that?
sure.
Everything.
Costs. Yeah, so a combination of all of that, right? So I think so. Cost is the first one, and the first that has triggered all the movement from away from copper to aluminum. So many a couple of decades ago already. That was the first trigger. And what happened then? So all the major technology leaders they have stopped to further develop the copper technology, right? So whatever you can find in copper today is still technology which is 40, 50 years old, and there's no more leading edge technology being developed with copper to increase efficiency and to reduce costs and all that. And in this meantime, right? So as we know, the heat exchange properties of copper are better than aluminum, actually, right? So in theory, it would make sense to have a more efficient cooler out of copper if we just talk about the metal which has been used there. But over all those decades we were talking about, so the technology on aluminum has developed so much, and with the same amount of material you can reach better thermal performance there, right? So cost, in summary, so cost is a big issue, and last but not least, right? So availability, yeah. So we know the U.S. Government has been struggling to find sources to keep the sustainment efforts on some vehicles, for example. So the M109 or the M103 troop carrier. So those are old designs, right? So old vehicles which are there in the field. So no new serial production, at least on most of the models. And there is a struggle to find replacement out of copper, and that's what we are trying to offer as a value here, right? So not to have our warfighter relying on coolers which are known to be problematic and being produced in smaller companies without the technology background that we bring to the table. So we understand we can with the transition from copper to aluminum, we can offer not only a competitive costing product, but as well something which is available in the latest technology in the market, and would be definitely more robust and reliable than what we see there as copper brass.
Awesome, thank you for that clarity. Hey, a couple questions are coming in. I know we're slowly running out of time, but do aluminum designs have larger footprint than copper designs?
No, usually not. So we can almost certainly fit an aluminum cooler with the same space claim as a copper cooler used to demand, right?
Okay.
So as I mentioned, so the newest aluminum designs, they are at least equivalent, and in most of the cases better in terms of performance density, if you want to call it like that. So meaning with the same footprint, with the same equipment size, we can extract the same, if not better, heat rejection.
This is an interesting question. Have your cooling systems been used in any solar arrays that are designed to store excess energy in battery configurations? And if they, and anywhere around the country, or is that a line of business for you at all, or maybe it's a good idea?
Right. So the answer is no. Yeah. So I'm not aware of any application there. So it could be that there is something on pre-development that I'm not aware of. But we'll be happy to take a look to that and to bring that to our management here and see if there is an opportunity for us to partner there.
Yeah, that's an interesting one.
The thermal management technology is there anyway, right?
Sure. One more question I think we have time for is what grades of aluminum do you typically use? Is there a typical grades that you guys work with, or grades?
For that, I'll ask for help for Henny Schroeder, our engineering manager. So
Yeah, a
I
couple of
won't be able
your
to-
colleagues
yeah.
colleagues unmuted here.
Yeah, so
Henny, can you help
mainly we
there?
use 3000 series aluminium, but we also, for certain parts of our coolers, we also use 6000 series.
Excellent. Okay, we certainly appreciate that. Hey, listen, we are slowly running out of time. Ciro and Ken and Henning, appreciate your presentation today. Appreciate your membership with Lyft. I want to thank everyone for joining today, and thank you guys for the presentation. Again, this has been recorded. It'll be up on our website at lyft.technology. Certainly by the end of the week. I encourage everyone to stay tuned to their emails. We do have another webinar coming up, as Monty Python would say, speaking of something completely different. We're working with Icon Technology Studio, talking about digital design, website interactivity, and virtual reality and augmented reality. So stay tuned for that on November 4th. In the meantime, I want to thank the MAHLE team. Ciro, again, thank you for your presentation today. We appreciate it.
Thanks,
I
everyone.
encourage everyone to reach out to them with additional questions and comments. And with that, we will see you next time. Thank you so much.
Thank you. Have a great day.